Section 1.6, Evaluating Functions. In this section, we will be evaluating functions. So a function from set A to set B is a relation that assigns to each element x in the set A exactly one element y in the set B. The set A is the domain, or the set of inputs, of the function, and the set B contains the range, or the set of outputs. In this section, we will use the notation f of x to represent that the variable y is a function of the variable x. We use letters such as f, g, h, r, and so on are used to name a function. The symbol f of x is read as the value of f at x, or f of x. The symbol f of x corresponds to the y value for a given x. Number 3, f of x is equal to x squared represents the variable y as a function of the variable x. The variable x is called the independent variable, and the variable y is called the dependent variable. So let's look at some examples. So in the first column, they give us the function f of x equals x plus 5, and they want us to evaluate the function at this function value, in this case f of negative 1. This represents the same thing as x is equal to negative 1. So when you see f parentheses negative 1, then the negative 1 is going to replace the value of x, or is going to replace x. So in this case, anywhere we see an x, we're going to replace it with negative 1. So here we have f of negative 1 is equal to negative 1 plus 5, and then we're going to evaluate it. So negative 1 plus 5 is equal to 4. And so what this means is that the value of x was negative 1, and when we evaluated the function, we got the value of y, which is 4. So that creates an ordered pair. Let's try another example. So here we have the function f of x is equal to x plus 5. In this case, we're going to be evaluating f of m. That means that x, anywhere you see an x, we're going to replace it with m. So in the function, for this x, I'm going to replace it with m. For this x, I'm going to replace it with m. So we get m plus 5. We cannot evaluate m plus 5, so we leave it as is. So my x value is m, and my y value is m plus 5. Let's look at the third example. G of x is equal to 5 minus 3x. In this case, we want to evaluate g of 2. That means that x is equal to 2. So anywhere we see an x, I'm going to replace it with 2. So I'm going to replace my x's with 2. So I get 5 minus 3 times x. So instead of x, I'm going to write 2. Then we want to simplify. So here we get 5 minus 6. 5 minus 6 is negative 1. So g of 2 is equal to negative 1. So that means that my ordered pair is going to be x is 2 and y is negative 1. Okay, let's go to the next one. G of x is equal to 5 minus 3x. We want to evaluate g of a. So anywhere we see an x, we're going to replace it with a. So I have an x here. I'm going to replace it with a. 5 minus 3 times x. A is going to replace the x. And we simplify. So we get 5 minus 3 times a is 3a. We cannot simplify any further, so my answer would be 5 minus 3a. So when x is a, we get 5 minus 3a. So the next one, h of x is equal to x squared minus 2x plus 1. We have h of 0. That means that our variable x will be replaced with 0. So we're going to have h of 0 is equal to 0 squared minus 2 times 0 plus 1. So everywhere that I see an x, I replace it with 0. So if we simplify, 0 squared is 0. Negative 2 times 0 is 0 plus 1. So that means that h of 0 is equal to 1. So when x is 0, our y is 1. And the last one here, we're trying to evaluate h of negative 1. So anywhere we see an x, we would replace it with negative 1. So we're going to have h of negative 1 is equal to negative 1 squared minus 2 times negative 1 plus 1. Negative 1 squared is positive 1 plus 2. Negative 2 times negative 1 is 2 plus 1. 2 plus 1 is equal to 4. So h of negative 1 is equal to 4. So when x is negative 1, our y is 4. Okay, let's try the next ones. So we have let g of x is equal to negative x minus 13. Find each function value. Okay, so we have g of x is equal to negative x minus 13. That's our function. And they want us to evaluate g of 2. So anywhere you see an x, we're going to replace it with the number 2. So we have negative 2 minus 13. Negative times 2 is negative 2 minus 13. And negative 2 minus 13 is negative 15. So g of 2 is equal to negative 15. And that would be our answer. Let's try letter B. So here we're trying to evaluate g of r. So anywhere you see an x, we're going to replace it with r. So here's an x. I'm going to replace it with r. Negative times r is just negative r minus 13. And we cannot simplify further. So this would be our answer. Letter C. We're trying to evaluate a plus b. So notice here that the entire thing is going to replace our x. So anywhere you see an x, we're going to replace it with a plus b. Okay, so if we simplify, we get negative times a is negative a. Negative times b is negative b minus 13. Okay, let's go to example 3. Let h of x equals 2x plus 4. Find each of the function values. So I always like to write down the problem and then do the evaluation. So here we're evaluating h of x. So notice here that we're going to replace x with x. So if I replace this x with an x and this x with an x, then we're going to be left with the same function. So h of x is just itself. Now let's try letter B. So now I want to replace x with x plus 2. So anywhere I see an x, I'm going to replace it with x plus 2. So 2 times x plus 2 plus 4. So we can simplify. I'm going to distribute the 2. 2 times x is 2x. 2 times 2 is 4 plus 4. So we end up with 2x plus 8. Letter C. Let's write the function down. So now for letter C, I'm going to replace with x plus h. So anywhere you see an x, we replace it with x plus h. I'm going to simplify. So I'm going to distribute the 2. 2 times x is 2x. Plus 2 times h is 2h plus 4. I cannot combine any terms, so this would be my final answer. Let's look at example 4. Let f of x equals x squared minus 4. Find each of the function values. So again, I like to write down the actual function, and then below it, I'm going to do the evaluation. So in this case, we want to evaluate the function at f of -2 at x equals -2. So anywhere you see a x, we're going to replace with a -2. -2 squared minus 4. So -2 squared is going to be a positive 4 minus 4, which is going to be 0. Okay, letter B. F of x, where we're going to replace it with itself. So my answer is just going to be f of x equals x squared minus 4. And now let's try the x plus h. So anywhere we see an x, we're going to replace with x plus h. So my x becomes x plus h, and x plus h squared minus 4. So here we want to simplify further, so we're going to multiply this out. So x plus h squared is the same as x plus h times x plus h. So we can distribute x times x is x squared, x times h is xh, h times x is hx, h times h is h squared minus 4. So if we gather our like terms, we're going to have x squared plus 2xh plus h squared minus 4. So here we have no like terms that we can combine. So this would be our final answer. Example 5. Let f of x equals x squared minus 2x plus 4. Find each function value. So here again, they tell us to find f of x, which if we replace x by itself, we get the same thing back. So my answer would be f of x equals x squared minus 2x plus 4. Letter B. So now we want to replace our x with x plus h. So anywhere that we see an x, we're going to replace with x plus h. So let me just write the function first. So for x squared, I'm going to replace with x plus h squared minus 2 times x plus h plus 4. If we simplify, x plus h squared is x plus h times x plus h. Distribute the -2, so we get -2x minus 2h plus 4. X times x is x squared plus xh plus xh plus h squared minus 2x minus 2h plus 4. Gather any like terms. So we get x squared, xh, and xh is 2xh plus an h squared minus 2x minus 2h plus 4. So now for letter C, they want us to subtract this function f of x plus h minus f of x. Well, we already know what we got for this. That was for letter B, so I'm going to write that down. Minus f of x. Well, f of x is what we got for letter A. So I'm going to put this in parentheses, which is very important. X squared minus 2x plus 4. And the reason you want to put it in parentheses is because we're subtracting the entire function. So without the parentheses, the negative would only be applied to the x squared. That's why it's important to have the entire parentheses. So if we simplify, we get x squared plus 2xh plus h squared minus 2x minus 2h plus 4. Distribute the negative. Negative x squared. Negative and negative is positive 2x. And negative times a 4 is negative 4. We want to see if we have any like terms. So notice I have a positive x squared and a negative x squared. So those are going to become 0, or we say we cancel them. We have a negative 2x and a positive 2x, so I'm going to cancel those. And positive 4 and negative 4 is 0, so I'm going to cancel those. So the only thing we have left is 2xh plus h squared minus 2h. So my answer when I take f of x plus h minus f of x is equal to 2xh plus h squared minus 2h. Okay, let's try another one. So here we have f of x plus h. So if I substitute into my equation, then I end up with anywhere I see an x, I'm going to replace with an x plus h. Notice that the negative is not being squared, so I have it on the outside. So if we rewrite this, that's x plus h times x plus h plus 2. X times x is x squared. X times h is xh. H times x is hx plus h squared plus 2. Distribute the negative, so we end up with negative x squared. Xh and hx is 2xh's. So if I distribute the negative, I'll get negative 2xh minus h squared plus 2. We cannot simplify any further, so this would be my answer. For f of x is just going to be itself. So I'm going to rewrite this here, negative x squared plus 2. And now they want us to subtract them again. And so for f of x plus h, we get negative x squared minus 2xh minus h squared plus 2 minus f of x, which is negative x squared plus 2. Let's distribute the negative, so we end up with negative x squared minus 2xh minus h squared plus 2. Negative negative is positive x squared minus 2. Combine any like terms. So we have a negative x squared and a positive x squared, so that's going to cancel or become 0. And so positive 2 and negative 2 cancel, become 0. And all that we have left is negative 2xh minus h squared. So when we subtract, we end up with this as our answer.